The 5 possibilities for life on Mars. For as long as humanity has been watching the skies, we've been fascinated with the possibility that other worlds much like Earth might contain living organisms. While our visits to the Moon taught us that it's completely barren and uninhabited, other worlds within our solar system remain full of potential. Venus might have life in its cloud tops. Europa and Enceladus might have life teeming in a subsurface ocean of liquid water. Even Titan's liquid hydrocarbon lakes provide a fascinating place to search for exotic living organisms. But by far, the most fascinating possibility is the red planet, Mars. This smaller, colder, more distant cousin of Earth most certainly had a wet past, where liquid water clearly flowed on the surface for more than 1 billion years. Circumstantial evidence has pointed to the plausibility of life on Mars, not only in the ancient past, but possibly still living and perhaps occasionally active even today. There are 5 possibilities for life on Mars. Here's what we know so far. With the information we've obtained from various orbiters, landers, and rovers, we've made a slew of fascinating discoveries on Mars. We see dried-up riverbeds and evidence of ancient glacial events on the Martian surface. We find tiny hematite spheres on Mars, as well as copious evidence for sedimentary rock, both of which only form on Earth in aqueous environments. And we've observed solid subsurface ice, snows, and even frozen surface water on Mars in real time. We've even observed what's likely to be briny surface water actively flowing down the walls of various craters, although the result is still controversial. All the raw ingredients that are required for life on Earth were abundant on early Mars as well, including a thick atmosphere and liquid water on its surface. Although Mars no longer appears as though it's teeming with life today, there are 3 pieces of evidence that past or even present life might be a possibility. The first compelling piece of evidence came from the instruments on board NASA's Mars Viking landers in 1976. There were 3 biology experiments performed: a gas exchange experiment, a labeled release. 1. Mars never had life on it. Despite having the same raw ingredients as early Earth and similar watery conditions, the necessary circumstances that enable life to form simply never occurred on Mars. All the geological and chemical processes that occur inorganically still happened, but nothing organic. Then, a little more than 3 billion years ago, Mars's atmosphere was stripped away by the sun, drying up any liquid surface water and leading to Mars's current appearance. This is the most conservative stance and would require that all 3 of the purported positive tests have either an inorganic or contamination-based resolution. This is eminently possible and remains, in the mind of many, the default assumption, until some very compelling evidence comes along that robustly points to either past or present life on Mars. This will likely remain the leading hypothesis. 2. Mars had life early on, but it died out. This scenario, in many ways, is just as compelling as the prior one. It's very easy to imagine that a world with a thick atmosphere similar to early Earth's, stable, liquid water on its surface, continents with rich geological diversity, volcanoes, a magnetic field, a day similar in length to our own, and temperatures only marginally cooler than Earth's today, could lead to life. To many, it's virtually impossible to imagine that these conditions, after more than 1 billion years, wouldn't lead to life. Considering that life arose on Earth no more than a few 100 million years after its formation. However, the loss of the Martian atmosphere had a profound effect on the planet and could have resulted in the extinction of all life on Mars. Drilling down into the sedimentary rock of Mars and searching for fossilized life forms or even metamorphosed carbon-rich inclusions could potentially reveal the evidence necessary to validate this scenario. 3. Mars had early life, and it still persists in a mostly dormant form beneath the surface. This is the most optimistic, but still scientifically viable, view of life on Mars. Perhaps life took hold early on, and when Mars lost its atmosphere, a few extremophiles remained in a sort of frozen, suspended animation state. When the right conditions emerged, perhaps underground, where liquid water can occasionally flow that life wakes up and begins performing its critical biological functions. If this is the case, then there are still organisms to be found beneath the Martian surface, perhaps in the shallow sands just a few feet or even mere inches below our spacecraft. We're likely only talking about single-celled life, perhaps not even reaching the complexity of a eukaryotic cell, but life on any world other than Earth would still be a revolution for science. NASA's Perseverance rover, which launched successfully on July 30, 2020, will collect critical soil samples to attempt to test this hypothetical scenario. 4. Mars didn't have life until Earth seeded it naturally. 65 million years ago, a very large, fast-moving body impacted Earth, creating Chicxulub crater and kicking up enough material to blanket the Earth in a cloud of debris, leading to the fifth great mass extinction in Earth's history. And like many massive impacts, this one likely kicked up small pieces of Earth all the way into space. The same way that impactors on the Moon or Mars send meteors throughout the solar system, where some of them eventually land on Earth. Well, a few impacts likely go the other way as well, sending Earth-borne material to other worlds, including Mars. It seems unreasonable that the material in Earth's crust, rich in organic life, wouldn't make it to Mars at all. Instead, it's eminently plausible that Earth-based organisms made it to Mars and began reproducing there, whether they thrived or not. Perhaps someday we'll be able to know the full history of life on Mars and determine whether any of it has the same common ancestor that all extant Earth life is descended from. It's a fascinating possibility that isn't easy to dismiss. 5. Our modern space program spread Earth-based life to Mars. And finally, perhaps Mars truly was a barren, lifeless planet at least for billions of years until the dawn of the space age. Perhaps spaceborne materials that weren't 100% decontaminated or sterilized landed on the Martian surface, bringing modern Earth organisms with them as stowaways. It's the ultimate nightmare of astrobiologists that there's a fascinating history of life to uncover on another world, but we'll contaminate it with our own organisms before we ever learn the true history of life on that world. In the worst case scenario, it could be the case that was surviving simple life on Mars of Martian origin, but that Earth life arrived and outcompeted it, driving it to a rapid extinction. This very real, healthy fear is why we're frequently so conservative, from a biological perspective, when we explore other planets and foreign worlds. There is a tremendous hope that current and future generations of Mars rovers and orbiters will help us finally puzzle out whether Mars, either now or at any point in its past, has ever harbored life. If the answer to that question is affirmative, then it leads to an important follow-up question. Is that life related to or independent of life on Earth? It is possible that life originated on Earth and seeded Mars with life. It's possible that life originated on Mars and then seeded Earth. It's even possible that life predated both Earth and Mars, and early forms of it took hold on both planets. But at this point in time, we have no overwhelming evidence that life ever existed on Mars at all. We have a few hints that could be indicators of past or present life there, but entirely inorganic processes could explain each and every one of those observed results. As always, the only way we'll find out the truth is by conducting more and better science with superior instruments and techniques. As NASA's Perseverance rover moves ahead to collect a variety of soil samples, the next step will be returning them to Earth for laboratory analysis. If we succeed at that, we could know for certain, within the next decade, which of these 5 possibilities is most consistent with the truth about Mars.